This video is the first video in a series to explain what torque is and how to find torque in different scenarios using real-world examples. So what is torque? Torque is a force that is causing an object to pivot or to want to pivot times the distance that force is from the pivot point. So in this first example, we have a torque wrench that there is a force going perpendicular to the wrench acting on it. The force going perpendicular is tangent to the circular path around the pivot point, so the total force will be going into making the part pivot. This means that we can take the force, which is 10.7 pounds, and multiply it times the distance to the pivot point, which is 0.75 feet, and we get a torque of 8.025 foot-pounds, or 10.9 newton meters for those of you who think in metric. On to our next example. We have a force that is going at a 30-degree angle from perpendicular and has a force of 12.29 pounds force. Notice that the force is not going tangent to the circular path. This means we need to break down the force into vectors using SOHCAHTOA in trigonometry so we can find the force causing the object to rotate. We break down the force vector and notice that the green leg is not causing a torque because it is not causing the torque wrench to want to pivot around the pivot point. Next, we break down the force vector into a blue vector that is going perpendicular to the handle of the wrench. This force is causing the torque wrench to pivot because it is tangent to the circular path around the pivot point. So we can plug this force into the torque equation along with the distance this force is from the pivot point, and we end up with a torque of 8.025 foot-pounds or 10.9 newton meters. For our next step, let's say we put a 90-degree bend in the torque wrench by adding a piece of wood. We apply a force of 10.7 pounds force, 0.75 feet from the torque wrench handle on the piece of wood. What will the torque be? We can think of this in two different ways. The first way is that the wooden 90-degree section is causing the part to pivot around where it is attached to the wrench. Where the extension is attached, it is transmitting the torque down the shaft of the wrench. This means that the length of the extension times the force that is applied is equal to the torque. So the torque equals 8.025 foot-pounds or 10.9 newton meters. The second way to view it is to find the force that is pivoting the torque wrench at its pivot point and the distance from the pivot point. If we do this by completing the Pythagorean theorem for the length and SOHCAHTOA to break down the force vector to get the force that is going tangent to the circle of rotation, we get 7.56 pounds force times 1.06 feet distance equal to 8.014 foot-pounds or 10.9 newton meters. This is close to the same value but very slightly due to the rounding and conversions of these numbers. Hope this video helped. This is intended as a brief introduction to the next videos, which we will go more into depth on how to find the torques, force, and distances with real-world applications. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Thank you for watching. I have also linked to the torque playlist.